Hello everyone, welcome back to ptet.chemistry channel. So this is the start of section 10.6. That is my categorization on carbonyl compounds. It's to do with aldehydes and ketone kind of chemistry. So in this question, it's basically just very standard nucleophilic addition reaction, because we do not use hydrogen cyanide when we do nucleophilic substitution. For example, when we want Rx going to RCN, right? So we would need a source of nucleophilic CN minus, instead using HCN, which is not very nucleophilic, all right? So this is your nucleophilic substitution, whereas here what we're doing is, let's say for example A, we're gonna have to end up doing it anyway. So we just drawing the skeletal. So carbon form 4 covalent bond. We show 1 there in a skeletal formula, meaning there's 3 more hydrogen which are not shown there. So when they add HCN, that is going to give you an addition reaction. So actually that is a reactant. So you could see 2 reactants combined together to give you 1 product, and that carbon is chiral because carbon forms 4 bonds. So there's a hydrogen there which I haven't shown because it's bonded to carbon. There's the hydrogen there which I haven't shown because it's bonded to carbon. And this is a skeletal formula. Alright, so very obvious A is the answer. But if I just draw for the rest of them, because it's very important practice to see what is going on, and that is my point when I go through these MCQ tutorials, that is not to just get the answer, because I always find MCQ is a good practice to cover theory revision as well. So here we have a CH3CH2, CH3CH2, C double bond O, CH2CH3. Hope you can see that this compound is symmetrical about the center. So whatever addition product that you get in the end, it is going to be the same on both sides, because you have 2 carbon there. You have 2 carbon. There's a ethyl group. This is a CH2CH3. You will have learned this in homologous series back in O level. These are called ethyl or CH2CH3 group. And then of course you would have the ester. This is an ester which you would have covered before as well in O level. Should probably draw my skeletal formula a bit better there. So O and then CH2CH3. This is an ester. It does not undergo a nucleophilic addition with HCN. This is called methanol. That is the official name. Chemists would have known it as a formaldehyde. Okay, so it's just the simplest aldehyde there is with 1 carbon. The formal name is obviously methanol. All aldehydes have an Al at the end, but a lot of people in the community will have known it as just formaldehyde. So we have formaldehyde. That is just the skeletal formula, believe it or not, it looks just like that. Okay, so I'm just going to draw a display because it's too simple anyway. So HCN, in case you don't know how it looks like, is a carbon sp hybridized there. And then if I start drawing display, I should probably display every single bond. The most common mistake when people draw display formula is they display everything, but they forgot about the OH bond, they forgot about the CN triple bond. Carbon from 4 bond, triple plus 1, that is 4. The oxygen from 2 bond, the carbon from 4 bond, 1, 2, 3, 4. Okay, it's an addition reaction, 2 become 1. There's 2 hydrogen there. This is not a chiral carbon. Okay, they want a compound with a chiral center. Carbon bonded to 4 different substituents, of which the hydrogen I haven't shown in that skeletal formula. So pretty straightforward then, but I've spent a bit longer on it to recap some concept which you might or might not have forgotten. Alright, so next bit is talking about properties. So it says neutral there. So meaning to say, I believe is to do with pH. So here you can see you have a carboxylic acid. So I can cross out these right away. Give an orange PPT with this 2,4-dinitrophenylhydrazine. This is hydrazine. This is hydrazine. Okay, 2,4-dinitrophenylhydrazine. That is NH and H2. This is 2,4-DNPH. Nope, it's not. This is position 1. This is position 2. There's NO2. This is position 4. There's NO2. 2,4-dinitrophenylhydrazine. phenyl. So you will learn more about this benzene ring. It's called a phenyl ring or benzene ring. Phenyl hydrazine, which is similar to this AS concept there, which you would have covered in structure and bonding. Okay. So the fact they give you an orange PPT with 2,4-DNPH means it has a ketone or it has an aldehyde. Okay, it must have a ketone or an aldehyde. Here what you have is you have an ester. Okay, C double bond O, there's an ester. This is a ketone. This is also a ketone. If I show it, then it's clear. If anything is unclear, you should always draw it out and see it for yourself. So I'm left with A or C, right? It evolved HCl when you treat it with PCl2 in the coal. So that third reaction there is a classic ROH to RCl using PCl5. Okay, so you need to balance the equation. They always ask in theory paper to write an equation to show the transformation. You should know the product, yeah? Okay, so that should have been covered in alcohol chemistry. You should also realize that because carboxylic acid has a OH bond, it's called a hydroxyl, you could also get that as well, plus PCl5. But we already established that this thing is neutral. So we are looking at the ketone, which has also a hydroxyl group. So it evolved HCl means it has hydroxyl group because you could replace the OH with Cl. Okay, so you must have a hydroxyl, you must have a ketone based on previous observation. So C must be the correct answer because it fits all the observations. All right. Next question. So this Russian composer Borodin. So quite an interesting backstory there. You form a compound commonly known as aldol. That's reaction 1. So this is your aldol product. And then the aldol can kick out water upon heating. It can kick out water. So they want the type, you see. This has been classified. This question should have been under introductory organic chemistry because it's basically identifying the type of reaction. If you think carefully, you have two molecules of it come together and you only get one molecule. It cannot be elimination because elimination is one becoming more than one. You eliminate something, right? You kick out something. Substitution means one thing become one thing. You just replacement. Or two things become two things. Replacement of one by the other. It has to be an addition because two things become one thing. So it has to be addition. Alright? So that's how you identify it. Second bit is, it's not a is it a reduction? Well, let's consider the second reaction. At first glance, I would think that it's elimination because it's one molecule going to two molecule. But let's see what is going on. CH3, so this is reaction 2, yeah? CH3, CHOH, CH2, so this is the aldehyde. And then I get that. And then I get an alkene. Oh yeah, okay, I hope you can see that now. It is very clearly an elimination because this is what I have eliminated. And I reformed the double bond there. So this is an elimination, no doubt about it, okay? It's not a reduction at all, alright? So it's an elimination, just in case you couldn't see it. So next question. So we talked about 2,4-DNPH just now. So the DNPH is capitalized, yeah? Dinitrophenyl hydrazine. Should keep in mind what it actually stands for instead of just using DNPH just like that. It's a test for aldehyde and ketone. So it tells you aldehyde or ketone because it reacts with the C double bond O of aldehyde or ketone. This is a ketone. This is an aldehyde. So both the aldehyde and ketones will react. Okay, both the aldehyde and ketone will react with 2,4-DNPH. Fehling's reagent is a source of copper. Copper 2 plus aqueous. So that is Fehling's. So it's pale blue solution. When you have aldehyde, you will do a redox reaction and you will get a brick red PPT. That brick red PPT happens to be copper 1 oxide. It's a copper 1 oxide. It is brick red in color. Okay, so there's Cu plus O2 minus. Okay, so there's the brick red PPT, and of course your aldehyde will become a carboxylate because this is under alkaline condition. So failing is not just copper 2 plus aqueous, it's alkaline aqueous copper 2 plus. So what you have is you get a carboxylate solution instead. Yeah. Sorry, you don't. Let me think about that. Yeah, you do have an alkaline solution of copper 2 plus, but it's not just hydroxide and this. There are something else in the Fehling's reagent which you don't need to know of, but it won't essentially give you the precipitate because there's something else in there besides just hydroxide and the copper 2 plus, right? Okay, so this brick red precipitate is the copper oxide, and you will get a carboxylate. You won't get the carboxylic acid. You will get the carboxylate salt because you are in a alkaline condition. In fact, not just the Fehling is alkaline, the Tollens reagent is also alkaline. Yeah? So that is only reactive for aldehyde. That is just R, so it's just R only, because the ketone can't be oxidized further. There's no hydrogen on the carbon with the ketone to be lost. So you don't have any hydrogen on this carbon, you cannot lose hydrogen, you cannot be oxidized further. That's the context of oxidation in organic chemistry. So next bit is a two-step reaction. When you have propanol, it's a 3-carbon ketone. When you add it with HCN, I hope without drawing the mechanism, you can see that it's a addition reaction. It's a nucleophilic addition reaction. You have a H, which, oops, sorry, you do not have a H. You have the CH3 and the CH3 originally, and then the O become a hydroxyl. I hope you know the mechanism. If you're unaware of the mechanism, you can watch my, you can navigate through the playlist on this channel and watch the A-level concept under organic mechanism. And there's a whole 15 minutes video on nucleophilic addition where hopefully it will help you understand the mechanism a lot better. Now you hydrolyze it under acidic condition. So that is hydrolysis. Typically, you will need dilute HCl or dilute H2SO4. You also need to reflux it. So it is this group that get hydrolyzed. The alcohol remains. So what happens is the nitrile, this is called the nitrile functional group, can get hydrolyzed under acidic condition to give you the carboxylic acid. This carbon comes from this carbon. So they want the structural formula. So if I convert that into structural formula, I will have CH3 twice carbon with a OH and CO2H. So there's the CH3 twice. This is the carbon. The OH has to be put in a bracket to avoid confusion. And then there's the CO2H, which means D is the only correct answer. Okay, so this is it for this 5-question series of the first MCQ series on carbonyls, ketones and aldehyde. So I'll see you in the next video. Thank you for watching. Please subscribe to the channel if you haven't. Please share the channel with your friends, your colleagues and your students so that more people can benefit from this video.